All right, let's do it. Time for a deep dive into hacking, the art of exploitation.
Sounds good.
This book, well, it kind of pulls back the curtain on how vulnerabilities in programming and networks, how they can be exploited.
Right.
And luckily, I've got an expert here to help break it all down.
Happy to be here. Always been fascinated by how these exploits work.
Yeah.
The ingenuity, the deviousness of it all.
Right. So before we get into the really complex stuff about how these things actually work, the book starts with some programming fundamentals. It's like you got to lay the foundation before you can build the house, right?
Absolutely. Couldn't agree more. You can't really understand how to break something unless, like how it was built in the first place.
Exactly. Okay, so let's talk about memory segmentation. The book uses a C program called memorysegments.c as an example.
Uh-huh.
Can you explain what that's all about?
Okay, so think of it this way. When a program runs, right, it needs space to store its data and instructions.
Yeah.
So memory segmentation is all about organizing that space into different zones, different segments, each with, a specific purpose. Kind of like how a city has residential areas, commercial, industrial. You get the idea.
Oh, okay. So it's not just like a big jumble of data all mixed together.
No, not at all. The memory segments.c example, it shows how the stack, heap, data, and B segments, well, they each hold different types of information. And understanding where things are stored, well, that's key for understanding how an attacker could manipulate them.
Oh, I see. So how does this memory segmentation tie into actual exploits?
Well, one of the most classic exploits is the buffer overflow. You familiar with the Morris worm?
Oh, yeah, vaguely.
Wreaked havoc back in the 80s by exploiting buffer overflows in a Unix program.
Wow, so like a single programming error can cause that much chaos?
Yep. So a buffer, it's basically a designated area of memory set aside to hold data.
Okay.
But if the program, if it doesn't check the size of the input properly, you see an attacker can just cram in more data than the buffer can handle, overflowing it.
Okay, so I'm picturing like a glass of water overflowing. But what actually happens when a buffer overflows in a program?
So that excess data, it spills over into the adjacent memory. And it could potentially overwrite, important information. Like in the case of the Morris worm, it overwrote instructions that controlled the program's execution flow.
So the attacker was able to basically hijack the program and make it do whatever they wanted.
Exactly. Imagine being able to redirect traffic on a highway just by changing a road sign. Right?
Oh, wow.
That's kind of what a buffer overflow allows an attacker to do.
Okay.
To redirect the program's execution to their own malicious code, which we call shell code.
Shell code, got it. And the book goes into even more detail about this using the authOverflow.c example, right?
Right, yes. That example shows how an attacker can manipulate a function's return address, which is like the program's GPS, and tells it where to go next. So by overriding it, they can point the program to their shellcode.
Sneaky. That's pretty clever, but also kind of terrifying.
It is.
And to make things even trickier, attackers can use techniques like NOP sleds,
Yes.
which the book mentions as a way to make their shellcode more reliable. What's a NOP sled?
Okay, so an NOP sled, right? It's like, imagine laying down a slip and slide for the program's execution flow.
Okay.
It's a sequence of no operation instructions. They don't actually do anything except take up space in memory.
And why would they want to do that?
Well, it basically increases the chances that the program, after being redirected by the buffer overflow, right, it'll land somewhere within that NOP sled, and then eventually slide down to the attacker's shellcode. It's all about, increasing the odds of success.
That's clever, but also devious.
Yeah.
It seems like attackers are always finding really creative ways to exploit these seemingly small programming oversights.
Yeah, they are.
I'm starting to see how important it is for programmers to really understand the security implications of their code.
It is, absolutely. And that's why the book throws in that challenge for the reader, asking them to spot the buffer overflow bug in the notesearch.c program.
Right. It's like a little test to see if you've been paying attention.
Exactly. And it highlights the fact that even seemingly simple programs can have these critical vulnerabilities.
Right. Yeah. Okay, so we've covered buffer overflows, which seem to be all about overwriting data to manipulate the program's execution flow.
Right.
But the book also mentions format string vulnerabilities, which sound even more confusing.
Okay, so format string vulnerabilities, right? They exploit the way a program handles formatted output. Like when you're printing text to the screen.
Okay.
Imagine you have a template with blank spaces, to fill in information, like name, address, and so on. Well, with a format string vulnerability, an attacker can manipulate those blanks, injecting their own commands instead of data. It's like turning those blank spaces into rogue instructions.
So instead of just overwriting data, they're actually manipulating like the instructions themselves.
Exactly. They can trick the program into executing their commands, you know,
Right.
potentially gaining control or even causing it to crash.
And the book connects this to real-world scenarios like the note search exploit. It shows how like user-supplied input can be manipulated to gain access to sensitive data.
Right. And that's why any program that takes input from a user, it could be vulnerable if it doesn't properly, validate and sanitize that input.
So it's not enough to just write code that works. You have to write code that's secure.
Exactly. And that's where security awareness and defensive programming techniques come in.
Right.
But before we get into those, let's maybe take a step back and look at the bigger picture of networking,
Okay.
because that's where things can get really interesting.
Okay, I'm ready to expand our horizons. But first, I think our listeners might need a moment to digest all this information about programming and exploitation. We'll be right back with more from Hacking, the Art of Exploitation. Okay, so we've dug into how vulnerabilities in programming, how those can be exploited.
Right.
But now I kind of want to zoom out a little bit. Look at the network itself. This is where things get really scary, right?
It is. Yeah, when we start talking about networking, the potential for damage, well, it just expands exponentially. It's not just about compromising a single program anymore. It's, gaining access to entire systems, stealing data,
Yeah.
disrupting critical infrastructure even.
The book lays out the basics of the TCP/IP protocol suite. Why is this so important for understanding, network attacks?
Well, think of TCP/IP as like the language of the internet.
Okay.
It's the set of rules that govern how data is transmitted between computers.
Mm-hmm.
So if you want to exploit vulnerabilities in network systems, you got to, speak the language.
So attackers are essentially learning to speak the language of the internet in order to exploit it.
Exactly. And they're not just passively listening. They're actively manipulating conversations, injecting their own messages, even impersonating legitimate participants.
Okay, starting to sound like a spy thriller.
It is, a little bit.
Can you give me like an example of how an attacker might exploit a network protocol?
Okay, sure. Let's talk about ARP poisoning. Remember how we talked about AMC addresses being like the computer's unique physical address on a network?
Yeah, it's how devices find each other on a local network, right?
Right, exactly. Well, the Address Resolution Protocol, ARP, it's responsible for translating IP addresses to AMC addresses. But this process, it can be manipulated.
So an attacker could like create fake ARP messages.
Exactly. By sending out these spoofed ARP messages, they can trick computers into associating the wrong MZ address with a particular IP address.
So if I'm, on my computer trying to send sensitive information to my bank's website, an attacker could use ARP poisoning to redirect that traffic to their own machine.
Exactly. They're essentially acting as a man in the middle, intercepting your data before it reaches, the intended destination.
That's scary. And the book even mentions that there are tools like DSNF that can make capturing this data surprisingly easy.
Yeah, unfortunately. DSNF, that's a classic example of a network sniffing tool. It can passively monitor network traffic and capture sensitive information like usernames, passwords, if they're being transmitted in plain text.
Which is why using HTTPS and encrypting sensitive data is so crucial, right?
It is, absolutely. Encryption, that's one of our most powerful tools for protecting data in transit. But, even encrypted traffic isn't completely immune to attacks.
Wait, really? How can an attacker, break encryption?
Well, breaking strong encryption algorithms directly, that's extremely difficult.
Okay.
But there are other ways to exploit weaknesses in how encryption is implemented or used.
Okay. Can you give me an example of, a more sophisticated attack that can target even encrypted traffic?
Okay, sure. One example is TCP/IP hijacking. This involves manipulating the sequence numbers that are used in TCP communication to basically hijack an existing connection.
So they're essentially cutting in line and impersonating one of the parties in the conversation.
Exactly. And because they're taking over an existing connection, they can bypass authentication measures and potentially gain access to, sensitive data.
Wow. That's really sneaky, and it sounds like it'd be incredibly difficult to detect.
It can be, especially if the attacker is, skilled and knows how to blend in with legitimate traffic. And these kinds of attacks, they're not just theoretical. They've been used in real-world scenarios to steal data, disrupt critical services.
It's a little unsettling to think that someone could be, like, lurking on the network, eavesdropping on conversations and potentially manipulating them.
It is. It's a constant, cat and mouse game between attackers and defenders.
Right.
But it's not always about stealing data. Sometimes the goal is just to disrupt services.
You're talking about denial of service attacks.
Exactly. Denial of service, DOS attacks, they aim to overwhelm a target system with so much traffic that it becomes inaccessible to legitimate users.
Yeah.
Like, imagine flooding a website with so many visitors that it just crashes under the pressure.
Oh, yeah. I've definitely heard about these attacks taking down websites and online services. How do they actually work?
Well, there's a lot of different techniques, from simple floods of requests to more sophisticated attacks that exploit vulnerabilities in network protocols. The book mentions ping flooding as like a basic example.
So it's like bombarding a server with so many "Are you there?" messages that it can't respond to anything else.
Yeah, that's a good analogy. And things get even scarier when we talk about distributed denial of service attacks, or DDoS attacks.
Yeah, DDoS attacks. I've heard those can be, like, incredibly powerful and difficult to stop. What makes them so different?
Well, DDoS attacks, they use a network of compromised machines called a botnet to launch the attack. So imagine, thousands, even millions of computers all flooding a target with traffic at the same time.
That's like a zombie army of computers all attacking at once. No wonder they're so effective.
Yeah, exactly.
Yeah.
And because the attack is coming from so many different sources, it's incredibly difficult to block. DDoS attacks have been used to take down websites, disrupt online gaming, even interfere with critical infrastructure.
Okay, we've covered some pretty scary scenarios here. It kind of sounds like the internet is a bit of a Wild West when it comes to security. But the book also talks about, countermeasures, ways to defend against these attacks, right?
It does, absolutely.
Yeah.
It's not all doom and gloom. There are a lot of things that we can do to protect ourselves and our systems from these threats.
Well, I'm ready to hear about some solutions. What are some of the, key takeaways from the book in terms of defending against these network attacks?
Well, one of the most important principles is defense in depth.
Okay.
So it's about having multiple layers of security in place so that if one layer fails, there are others to back it up.
So it's like having a castle with multiple walls and moats.
Exactly. And these layers, they can include things like firewalls, intrusion detection systems, strong authentication mechanisms.
Okay, let's break those down a little bit. What exactly is a firewall, and how does it help protect a network?
A firewall acts as a barrier between your network and the outside world. It examines incoming and outgoing traffic and blocks anything that doesn't meet certain criteria.
So it's like a security guard, like checking IDs at the entrance to your network.
Yeah, that's a good way to think about it. Firewalls can be configured to block traffic based on, source and destination IP addresses, port numbers, other factors.
And what about intrusion detection systems? How do they differ from firewalls?
So while firewalls primarily block traffic, intrusion detection systems, or IDSs, they're designed to monitor network activity and alert you to any suspicious behavior.
So it's like having security cameras watching for intruders?
Exactly. IDSs, they can analyze network traffic patterns, looking for anomalies that might, indicate an attack. They can also be configured to take automated actions, like blocking traffic or logging the event.
That sounds pretty sophisticated. But I imagine attackers are, constantly coming up with new ways to bypass these defenses.
Oh, yeah, you're absolutely right. The world of cybersecurity, it's a constant arms race. As defenders develop new security measures, attackers are always looking for ways to circumvent them.
So it's not enough to just, set up a firewall and forget about it.
Not at all. Security, it requires ongoing vigilance, constant updates, and a willingness to adapt to new threats as they emerge.
Okay, so firewalls and IDS are important layers of defense. But what about authentication? How does that fit into the picture?
Authentication is all about verifying the identity of users and devices that are, trying to access your network. It's like having a password to enter a restricted area.
So strong passwords are essential.
Absolutely. Strong passwords, along with other authentication factors like biometrics or two-factor authentication, they can make it much harder for attackers to gain unauthorized access.
It sounds like securing a network involves a multifaceted approach
Right.
with multiple layers of defense working together to protect against a wide range of threats.
Yeah, it does, yeah. And it's important to remember that security isn't just about, technology, it's about people too.
What do you mean by that?
Well, even the most sophisticated security measures can be undermined by human error.
Right.
Things like, clicking on phishing links, using weak passwords, or falling for social engineering scams. These can give attackers a really easy way in.
So educating users about security best practices is just as important as, implementing technical safeguards.
It is, absolutely. Security awareness training can help users understand the risks and how to avoid them. It's about creating a culture of security within an organization.
Okay, so we've talked about firewalls, IDSs, strong authentication, and security awareness training. Are there any other key takeaways from the book in terms of network security?
Yeah, the book really emphasizes the importance of regular security audits and penetration testing.
Penetration testing. Isn't that what ethical hackers do?
It is, yeah. Penetration testing involves simulating real-world attacks to identify vulnerabilities before they can be exploited by, malicious actors.
So it's like hiring a professional burglar to test your home security system.
That's a good analogy. Penetration testers use the same tools and techniques as attackers, but with the permission of the system owner, obviously, to find and exploit weaknesses.
It sounds like a valuable way to identify and fix vulnerabilities before they can be, actually exploited.
It is. Penetration testing can help organizations get a realistic assessment of their security posture, identify areas that need improvement.
Okay, so we've covered a lot of ground in terms of network security. We've talked about threats, vulnerabilities, countermeasures.
Yeah.
But there's one more crucial area that we need to discuss: cryptography.
Right.
Cryptography is what? The art of secret codes.
It is, yeah. It's about protecting information by transforming it into a form that's unreadable without the proper key.
And this is essential for, securing data in transit as well as data at rest, right?
Absolutely.
Yeah.
Cryptography, it's used to protect everything from online banking transactions to confidential emails to sensitive government data.
Okay, I'm ready to dive into the world of cryptography. But first, let's give our listeners a moment to, catch their breath. We'll be right back with the final part of our deep dive into hacking, the art of exploitation.
Okay, we're back, ready for the last part of our deep dive into hacking, the art of exploitation.
We have covered a lot, from how software works to, the crazy world of networks.
And now we're diving into cryptography, the world of secret codes and all that.
Yeah, cryptography. Always found it fascinating. It's math, computer science, a little bit of espionage even. So the book, it starts with the basics, explaining symmetric versus asymmetric encryption. Can you break that down for us?
Sure. So imagine, you and a friend want to exchange secret messages.
Okay, like passing notes in class.
Exactly. So symmetric encryption, that's where you both use the same key, right, to encrypt and decrypt those messages.
So, you have a shared secret code.
Exactly. But the problem is, how do you securely share that key in the first place, right? That's where asymmetric encryption comes in.
Right. Okay. How does that work?
So in asymmetric encryption, there's two keys: a public key that you can share with anyone and a private key that you keep secret.
So I could post my public key on a billboard,
Yeah.
and anyone could use it to send me an encrypted message.
Exactly. But only you, with your private key, you can decrypt those messages.
That's clever. The book mentions algorithms like DES and triple DES as examples of symmetric encryption, and RSA as an example of asymmetric encryption.
Yeah.
What makes them so secure?
Their security is based on how hard it is to solve certain math problems, like take RSA. It's based on how hard it is to factor large numbers into their prime components.
So it's like a math puzzle that's almost impossible to solve without the right key.
Yeah, pretty much. And as computers get more powerful, we need stronger algorithms to stay ahead, which is why the book also talks about quantum cryptography, which is a whole other level.
We talked about it a little before, but I'm still not quite sure what quantum cryptography actually is.
It's a newer field.
Yeah.
And it uses, quantum mechanics to create super secure communication channels.
Quantum mechanics, that sounds complicated.
It is a bit.
Yeah.
But the basic idea is that quantum cryptography uses photons, those are particles of light, to transmit information in a way that can't be intercepted without, being detected.
So it's like having an alarm system that goes off if someone tries to eavesdrop.
Exactly. Quantum key distribution, for instance. That lets two parties share a key, and it's provably secure thanks to the laws of physics.
Wow, sounds like sci-fi, honestly.
It does. But it's already being used for, some high security stuff. And as quantum computers get more powerful, quantum cryptography is going to be even more important in keeping our digital world secure.
So we've gone from basic encryption to like the crazy world of quantum cryptography. It's amazing how far this field has come.
It is, and it keeps changing. But even with, the most advanced cryptography, security isn't just about the technology. It's about people, too.
You keep saying that. Why is the human element so important in cryptography?
Because even the strongest encryption can be messed up by human error. If someone, uses a weak password or falls for a phishing scam or accidentally exposes their private key, the whole system is vulnerable.
So like it's having a high-tech security system, but leaving the front door wide open.
Exactly. Security awareness and good practices. Those are crucial to making cryptography really work.
Well, I think we've covered so much in this deep dive into hacking, the art of exploitation. We've gone through programming, networks, cryptography,
It's been a journey.
and we've seen how attackers can find those weak points in all those areas.
They're clever, that's for sure.
But we've also seen how people are fighting back, right? Coming up with new ways to protect our digital world.
That's the important part.
It's a constant battle.
Yeah.
But we can win it if we understand the threats and take the right precautions.
Absolutely. And remember, the more we know about how hacking works, the better we can defend ourselves.
Well said. Thanks so much for guiding us through this. It's complex, but it's fascinating.
Happy to do it.
And to all our listeners, thanks for joining us for this deep dive. Hope you learned something new and that you'll keep exploring this world of hacking and cybersecurity. Stay curious, stay informed, and most importantly, stay safe out there.